Assalamualaikum warahmatullahi wabarakatuh. So in lesson 9 class, we will tackle about the analytic geometry in 3 dimensions. So sa Math 111 kasi class is 2 dimensions lang yon. So ang ibig sabihin nun, x and y lang yung variable na ginagamit doon. Pero dito sa Math 131E or Analytic Geometry in Calculus 2 is 3 dimensions na tayo. Ibig sabihin, we have the variables x, y, and z. So, ito yung example ng 3-dimensional coordinate system. So, di ba ang alam lang natin na coordinate system is the x and y axis, x and y coordinate plane. Si x is dito si, kumbaga ganito. This is y axis and then this is x axis. So, dito sa 3-dimensional coordinate system class, nadagdagan na siya ng z axis. So, this is our x axis. This one is our y axis naman. And then, eto yung nadagdag na si z axis. This is the origin. In this lesson class, we introduce vectors and coordinate systems for 3-dimensional space. This will be the setting for our study of the calculus of functions of 2 variables. At the end of this lesson, you will be able to see that vectors provide particularly simple descriptions of lines and planes in space. So, ang pag-uusapan na natin dito is space na kasi 3-dimensional naman tayo. So, in this module, we'll talk about the 3-dimensional coordinate system una. And then after that, the distance formula in 3 dimensions. Meron din tayong distance formula in 2 dimensions, di ba? Pero parehas lang sa 3 dimension, but nadagdagan lang siya ng variable z. And then lastly, the direction, cosines, and numbers. To locate a point in a plane, 2 numbers are necessary, right? Kung plane yung pinag-uusapan, 2 numbers yung kailangan natin. We know that any point in the plane can be represented as an ordered pair AB of real numbers, where A is the x-coordinate and B is the y-coordinate. Kung plane yung pinag-uusapan, ordered pair lang yung kailangan natin, or 2 numbers, where may tinatawag tayo ng x-coordinate at y-coordinate. For this reason, a plane is called 2-dimensional. Okay, kung plane yung pinag-uusapan, yun yung tinatawag natin na 2-dimensional system. To locate a point in space, kung space na yung pag-uusapan natin class, 3 numbers are required. So, we represent any point in space by an ordered triple. Okay, so hindi na ordered pair, kundi ordered triple, A, B, and C of real numbers. In order to represent points in space, we first choose a fixed point 0 or O, that is the origin, and then 3 directed lines through O that are perpendicular to each other, called the coordinate axis, and labeled the x-axis, the y-axis, and the z-axis. Usually, we think of the x and y-axis as being horizontal. Okay? We think of x and y, si x and y as being horizontal, and then z-axis as being vertical, so 3-dimensional. And we draw the orientation of the axis as in this figure. So, this is the x-axis, this one is the y-axis, so horizontal siya, and then yung z-axis natin is vertical. Direction of the z-axis is determined by the right-hand rule. So, eto, na-introduce to sa physics, sa first physics ninyo, right-hand rule, as illustrated in this figure. So, let's say, eto yung right hand, then eto yung thumb. Yung thumb natin is yan yung direction of the z-axis, kasi vertical man. Okay? Eto yung x-axis natin. This one is the origin. Let's say, nandyan sa gitna. May point tayo sa gitna ng thumb natin, sa hand natin rather. And then, This is the y-axis. So if you curl the fingers of your right hand around the z-axis in the direction of a 90-degree counterclockwise rotation from the positive x-axis, okay, from the positive x-axis to positive y-axis, then your thumb points in the positive direction of the z-axis. So, para madali nating matandaan yung third-dimensional coordinate system, pwede ninyong gamitin yung right-hand rule. Okay, so yung thumb ninyo is yan yung z-axis. And then, i-curl nyo lang siya. Okay, curl nyo lang. 90-degree counterclockwise rotation. So, from the x-axis, papunta siya kay y-axis. Okay, tandaan, pag plane yung pinag-uusapan, two-dimensional, ordered pair, dalawang numbers yung kailangan natin. Kung space yung pinag-uusapan, three-dimensional coordinates na yan. Ibig sabihin, ordered triple or three numbers yung necessary. The three coordinate axes determine the three coordinate planes. Illustrated in this figure, figure 3. A, the xy plane is the plane that contains the x and y axis. Okay, kung dito sa figure 3A coordinate planes, yung xy plane daw, eto siya, it contains the x and the y axis. Tama, di ba? And then the yz plane naman, class, it contains the y and z axis. And then the xz plane, it contains the x and z axis. These three coordinate planes divide space into 8 parts, which is called the octants. Okay, the first octant in the foreground is determined by the positive axis. So sa figure 3B, okay, let's say, eto, hanap tayo ng isang sulok sa bahay natin. Okay, let's say, eto yung isa sa wall sa bahay natin. Okay, eto yung floor. Tapos, yung nasa right wall, yan yung y-axis natin. And then, etong wall na to, kumbaga yan yung beam sa bahay ninyo. Yan yung z-axis natin. Tapos, yung etong side na to is yan yung x-axis natin. And this is the origin. Okay, this is y. So, madali lang. Tingnan nyo lang yung bahay ninyo, isang sulok sa bahay ninyo. Tingin kayo ng isang beam. Tapos, yung sa right wall, yun yung y-axis ninyo. And then, yung sa left wall is yun yung x-axis. Because many people have some difficulty visualizing diagrams of three-dimensional figures, you may find it helpful to do the following. In sa figure B, 3B, yung na-mention ko kanina. Look at any bottom corner of a room and call the corner the origin. Okay, sabi ko nga, tingin kayo na isang sulok sa bahay ninyo. The wall on your left is in the xz plane. Kasi di ba yung x-axis is nasa left wall man siya. And then the wall on your right is in the yz plane. And the floor is in the xy plane. Yung floor natin is yun yung xy plane. The x-axis runs along the intersection of the floor and the left wall. And then the y-axis naman runs along the intersection of the floor and the right wall. The z-axis runs up from the floor toward the ceiling along the intersection of the two walls. Tama, di ba? You are situated in the first octant. Okay. And you can now imagine 7 other rooms situated in the other 7 octants. 3 on the same floor and 4 on the floor below. Okay. 3 on the same floor. 1, 2, 3. And you can and 4 on the floor below. Sa baba, di ba? All connected by the common corner of point O. Okay. So try to imagine or try to picture out. Now, if T is any point in space, let A be the directed distance from the YZ plane. Okay, sa figure 4 natin. YZ plane, and from the YZ plane to P, this is our point P, and let B be the distance from the XZ plane, galing siya dito sa XZ plane, papunta dito sa point P na yan, and let C be the distance from the XY plane, okay, sa floor, to the point P. So we represent the point P by the order triple A, B, C of real numbers. And we call A, B, and C the coordinates. So ito yung tinatawag natin na coordinates. So pwede din na X, Y, Z. Okay. A is the X coordinate, and B is the Y coordinate, and Z is the Z coordinate. Thus, to locate the point A, B, C, we can start at the origin O and move A units along the x-axis, and then B units parallel to the y-axis. So, ang parallel, si B is parallel siya kay y-axis. Tama, di ba? And then C units parallel to the z-axis, as in this figure. So, kung makikita ninyo, si point B parallel siya kay y-axis. Si C naman is parallel siya kay z-axis. The point P determines a rectangular box, as in figure 5. Okay? So, mag-connect tayo ng mga points, makakabuo tayo ng rectangular box. If we drop it perpendicular from P, okay, from P to the XY plane, ito yung XY plane natin, we get a point Q. So, ito. If we drop point P here, perpendicular siya dito kay XY plane. So, ibig sabihin, perpendicular class is sa opposite direction. Pero may point of intersection sila. Kung parallel, the same yung direction, but wala silang point of intersection. Okay, we get point Q with coordinates A, B, and 0. So, ito yung ibig sabihin. And then, call the projection of P onto the XY plane. So, si P, ang projection niya is si point Q. So, similarly, si R naman, itong point na to, is siya yung, and the point S are the projections of P onto YZ. Si P, ang projection niya dito kay XZ is si S. Projection naman ni P dito sa YZ plane is si R. Okay. Kumbaga, yung mirror niya. Reflection, rather, or projection. As numerical illustration class, the points negative 4, 3, and negative 5. Let's say, ito yung given natin na point. So, ito yung graph niya dito sa first diagram ng figure 6. Okay, so si negative 4, yan yung sa x-axis natin or x-coordinate. And then 3 is, plot natin yan sa y-axis, sa positive y-axis rather. And then negative 5 is the z-coordinate. So, ibig sabihin sa negative side ng z-axis. So, unahin natin sa negative 4. So, since ito yung positive side ni x-axis, ang negative side niya class is doon sa taas. Okay. So, mag-count tayo ng 4. So, we have 1, 2, 3, 4. Let's say, 4 yung distance nito from the origin. So, let's say nandyan. And then, so lahat ng line na parallel sa x-axis is kailangan 4 yung distance niya. Okay, para makabuo tayo ng rectangular box. So, yung ibig ko sabihin class, let's say yan, parallel siya. Okay, ito yung sa negative x-axis, diba? So, etong line na to, parallel siya dito sa x-axis sa negative side. Also, ito din, ang distance din dapat niyan is 4 kasi parallel yan dito sa x-axis. And also, etong part na to, yan, is parallel din yan sa x-axis. Okay, yan yung mga parallel sa x-axis, yung red. Okay, may nakamark na red, ha? Okay, so ibig sabihin, yung distance niyan dapat is lahat 4. Okay. And then, next is C3. Okay. C3 class is, yan yung y coordinates. So, ibig sabihin, dito tayo titingin kay y-axis sa positive. So, let's say 1, 2, 3. So, ibig sabihin, lahat din ng line na parallel kay y-axis is dapat yung distance din niya is 3. Para, ang goal natin dito is makabuo tayo ng rectangular box. Okay, so eto, 3-man node. So, ibig sabihin, dito yung 3. So, parallel siya dito. So, etong line na to, etong yellow, yan, yung may nakamark na yellow, is parallel yan dito sa y-axis. Eto din siya class, kailangan distance din yan 3 kasi parallel yan sa y-axis. And also, etong sa baba, yung dashed line na yan, is parallel din siya dito sa y-axis. Ibig sabihin, ang distance din yan is 3. Okay, and then si 5 naman, si negative 5, z-coordinate yan. So, ibig sabihin sa negative side ni z-axis. Kung ito yung positive side ni z-axis, dito naman sa baba yung negative side niya. So, let's say, 1, 2, 3, 4, and 5. So, let's say nandito si negative 5. So, ang gagawin din natin dito class, lahat ng lines na parallel kay z-axis, let's say ito, okay, i-mark natin ng blue. Let's say itong part na to, parallel yan dito sa z-axis. Ang distance din dapat niyan is 5. Also, ito siya class, yung part na to, is yung distance din yan is dapat 5. And etong dashed line dito, ang distance din dapat niyan is equals to 5 din dapat. So, para makabuo tayo ng rectangular box. Okay. Uulitin ko, si negative 4 is nasa negative side ni x. Okay. So, since yung 3 is nasa positive y-axis, so, nandito si 3, mag-construct tayo dito ng parallel line from this point. Kasi, di ba, eto man yung negative 4 natin, no? So, construct tayo dito. So, ang distance niya, class, from here up to here is 3. Okay. So, si Mambusi Kuwan, na mapasado to na sa kanukman. Pag-construct tanukman saya sa line, blue saya, na dapat na distansya na 5 kasi na ay z-axis tanong kasi na equals to negative 5. So, z-coordinate yan. Na, taman sa pakapagpupunikaan yun na nakabalik pakabuka na saya sa rectangular box. Okay. Another example class. Etong point na 3, negative 2, negative 6. Okay. So, etong sa diagram na to. Si 3, okay. Eto pa rin yung z-axis natin na positive z-axis, positive x-axis, positive y-axis. Okay. Si 3, yan yung sa positive x-axis, diba? So, let's say, ito yung origin natin. So, let's count 3 points. So, we have 1, 2, and then, let's say 3. Okay, nandito siya yung 3. So, mag-start kayo dito kay 3. Tingnan ninyo kung ano yung y coordinates natin. So, since si y coordinate no class na negative 2, okay, negative 2. So, saya. So, ibig sabihin, ito yung positive direction ni y-axis. And then, yung sa left side, yung negative direction ni y-axis. So, ibig sabihin, sita na start 1, tapos 2. So, ginan 2. Na, padiba sis, kanyan, para kasi kasumpatan tanway, na pag-construct tayo saya sa line parallel sa y-axis. Sa aya distance yan ng dapat na 2. Okay, gini na aya distance saya na 3 kaparallel kanya saya sa x-axis. Si 6 na negative 6. Si z rather na negative 6. Ibig sabihin na saya sa baba ay z-axis. Okay. Let's say 6 sanan. 6 distance sanan. Na kung saya ka po-construct sa z-axis, sa line parallel saya sa z-axis na kailangan na distance yan ng na 6 ka para mapantay sa kanyang roo. Saya mambu na construct ka no sa z-axis na 6 mambu distansya. Na gito mambu, uon ro sa gito at turo o na distansya mambu na 6. Basta, ka-analyze yung buskan niya na pangbal ka no sa rectangular box. Depende kung tunay given na points. Kung 3, so x-axis na 3, na lang na line ay pag-construct yung parallel si ko x-axis na 3 dapat sa distansya yan. Sagi example si A. Kung so y mambu na 2, na kailangan na lang na line na parallel ay pag-construct yung si ko parallel si ko y-axis na lang dapat 2 sa distansya yan. Kung so z mambu na 6, na kailangan na lang ni pag-construct yung line na parallel sa z na 6 mambu dapat sa distansya yan. The Cartesian product, okay, r times r times r is equal to x, y, z, such that x, y, z is in R is the set of all ordered triples of real numbers and is denoted by r cubed, or eto yung symbol ng space. Kung r squared, plain lang yun class. So we have given a one-to-one correspondence between points P in space and the ordered triples ABC in R cube. So it is called a three-dimensional rectangular coordinate system. So please try to graph. Paki-graph ito ulit kung magaya ninyo ito. Ibig sabihin, naintindihan ninyo kung paano mag-graph na three-dimensional. Basta ang goal ninyo dyan, class, mag-construct kayo na, makabuo kayo ng rectangular box. Okay, so notice that in terms of coordinates, the first octant can be described as the set of points whose coordinates are all positive. In two-dimensional analytic geometry, the graph of an equation involving x and y is a curve in r squared. So in three-dimensional analytic geometry naman, an equation x, y, and z represents a surface. Okay, kung sa two-dimensional analytic geometry, yung equation involving x and y is a curve. Okay, and then sa three-dimensional naman in analytic geometry, yung x, y, and z na equation represent the surface. Okay, for example, what surfaces in our cube are represented by the following equations? Okay, first is z equals to 3. Okay, in surface ha, 3 dimension. And then the second one is y equals to 5. So unahin natin yung z equals to 3. The equation z equals to 3 represents the set x, y, and z such that z equals to 3, which is the set of all points in R cube, whose z coordinate is 3. So ibig sabihin lang ng z equals to 3, ang z coordinate natin is 3. So this is a horizontal plane that is parallel to the xy plane and 3 units above it as in figure 7a. So ang graph ng z equals to 3 class, since diba ito yung z axis natin, so mag-count tayo ng distance na 3. So yan, ibig sabihin mag-construct lang tayo ng line dyan na parallel perpendicular sa z. So ang mabubuo natin is a plane lang siya. Okay. Sa letter B naman, the equation y equals to 5 represents the set of all points in R cube whose y coordinate is 5. So this is the vertical line plane that is parallel to the xz plane and 5 units to the right of it as in figure A. Okay, so eto sa figure B. So vertical line siya parallel sa xz plane. So this is our xz plane. So parallel siya dito. So when an equation is given, class, we must understand from the context whether it represents a curve in R squared or a surface in R cube. So in example 9.1, y equals to 5 represents a plane in R cube. But of course, y equals to 5 can also represent a line in R squared. Tama, di ba? If we are dealing with two-dimensional analytic geometry, so in figure 7b and figure 7c, so kung pinag-uusapan is in plane, what I mean is in surface, plane yung line equation natin na y equals to 5. Kung two-dimensional naman or in r squared or sa plane siya class, ang equation na y is equal to 5 is just a line. So, eto, line siya. Yun yung pinagkaibahan. 3D, 3-dimensional. Kaya nga siya tinawag na 3-dimensional. Okay. So, in general, if k is a constant, then x equals to k represents a plane parallel to the yz plane. Y equals to k is a plane to the xz plane, and z equals to k is a plane parallel to the xy plane. Okay. Kung yz plane, x is equal to k, parallel siya dito sa yz plane. Kung y is equal to k naman, parallel siya sa xz plane. And then, kung z equals to k, ibig sabihin, ang given equation is z is equal to 1. Yung plane na yun is parallel siya sa xy plane. So, in figure 5, the faces of the rectangular box are formed by 3 coordinate planes. X equals to 0, the yz plane. Kung y equals to 0 naman, that is the xz plane, and z equals to 0 naman, the xy plane. In the planes x equals to a, y equals to b, and z equals to c. Another example is which points x, y, z satisfy the equations x squared plus y squared equals 1 and z equals to 3. Second one is what does equation x squared plus y squared equals 1 represents as a surface in R cube or in space. Unahin natin yung sa first example. Because yung z equals to 3 class, the points lie in the horizontal plane z equals to 3 from example 9.1. So, ang graph nito is a horizontal plane, yung sa previous example natin. Then, yung x squared plus y squared equals 1 is, that is a circle. The points lie in the circle with radius 1 and center on the on the z-axis. So, ito yung figure niya. So, if this is our z-axis, so ito yung 3, z equals to 3, diba? So, dito tayo magpo-construct ng circle. Dito natin i-construct yung circle natin na x squared plus y squared with radius. X squared plus y squared equals 1 with radius, a circle with radius 1. Okay. Given that, yung sa letter B naman, given that x squared plus y squared equals 1 with no restrictions in z, we see that the point x, y, z could lie on a circle in any horizontal plane, z equals to k. So, the surface x squared plus y squared equals 1 in R cube consists of all possible horizontal circles. X squared plus y squared equals 1, z equals to k, and therefore, the circular cylinder with radius 1 whose axis is the z-axis. So, kung walang restriction ng z-class, pag i-construct na natin yung when z is equal to k, and then possible na yung x squared plus y squared equals to 1 in R cube consists of all possible horizontal circles. So, let's say ito, may nabuo tayong mga horizontal circles dito. Center niya is the z-axis. Let's say z is equal to k. Let's say z is equal to 1. Pwedeng dito tayo mag-construct ng circle na ang radius niya is equal to 1. So, ang mabubuo natin is a cylinder. For the last example sa tawag dito, 3-dimensional coordinate system. Describe and sketch the surface in R cube represented by the equation y equals to x. So the equation represents the set of all points in R cube. Its x and y coordinates are equal. So that is x, y, z, x is in R, and z is in R. So this is a vertical plane that intersects the xy plane in the line y equals to x and z equals to 0. So the portion of this plane that lies in the first octant is sketched in figure 10. So ito yung plane natin na y equals to x. A vertical plane that intersects the xy plane, okay, in the line y equals to x, tapos z equals to 0. So next is the distance formula in three-dimensional coordinate system. The distance absolute value p sub 1 and p times p sub 2 between the points p sub 1, x sub 1, y sub 1, z sub 1, and point p sub 2 with x sub 2, y sub 2, and z sub 2 coordinates is the absolute value of p sub 2, 1 times p sub 2. So, ito yung distance formula. So, yun nga yung na-mention ko kanina. The same lang doon sa 2-dimensional but nadagdagan lang siya ng isang variable na z. To see why this formula is true, we construct a rectangular box as in this figure. So, ito yung dito nanggaling yung formula na ito. Where p sub 1 and p sub 2 are opposite vertices, okay, and the faces of the box are parallel to the coordinate planes. If A and B are the vertices of the box indicated in the figure, then the absolute value of p sub 1a equals to the absolute value of x sub 2 minus x sub 1, and then the absolute value of ab equals to the absolute value of y sub 2 minus y sub 1, and also the absolute value of p times p sub 2 is equal to the absolute value of c sub 2 minus c sub 1. This is minus. Because triangles p sub 1b, p sub 2, and p sub 1ab are both right angled, two applications of the Pythagorean theorem give. Okay, so the Pythagorean theorem, and ito din equal siya. Combining these equations, we get, okay, so therefore, the absolute value of p sub 1 times p sub 2 is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared plus z minus z sub 1 quantity squared. For example, the distance from the point P to negative 1, 7 to the point Q, 1, 3, negative 1, negative 3, and 5 is, okay, so yung distance niya using the distance formula lang. So, x sub 2 minus x sub 1 is magiging 1 minus 2, quantity squared, negative 3 minus negative 1, 5 minus 7. So, substitution na ang class. Ibig sabihin lang nito is the distance of the point P from to the point Q. Okay, so just use the formula of the distance. And then next example class, find an equation of a sphere with the radius r and center c, h, k, l. Okay, sphere, 3 dimension. So by definition, a sphere is the set of all points P, x, y, z whose distance from C is r. So in this figure, ito siya. If this is our sphere, ito yung center niya na HKL, and then yung distance from the center to the point P is R. So that's P on the sphere. That's P on the sphere if and only if the absolute value of P, and here the distance from P to the point C is equal to R. Squaring it both sides, we have the absolute value of PC squared is equal to r squared, or eto yung ma-obtain natin na equation ng sphere. X minus h quantity squared plus y minus a quantity squared plus z minus l quantity squared equals to r squared. So, parehas lang doon class sa formula ng circle, but x and y lang, and then yung center ng circle natin is hk. Sa sphere is nadagdagan siya ng z, then l yung center. Equation of a sphere. An equation of a sphere class with center C, H, K, L, and radius R is this one. So yung na-derive natin sa example sa previous slide. In particular, if the center is the origin, then an equation of the sphere is, okay, kung ang center natin is at the origin, ang magiging equation ng sphere natin is x squared plus y squared plus z squared equals to r squared. Kung center is the origin, ibig sabihin 0, 0, 0 si h, 0 si k, 0 si l. Okay. For example, show that x squared plus y squared plus z squared plus 4x minus 6y plus 2z plus 6 equals 0 is the equation of a sphere and find its center and radius. So, parehas lang din ang pag-solve doon sa paghanap ng equation ng circle class. We can rewrite the given equation in the form of an equation of a sphere if we complete squares. So, ibig sabihin, by completing the square, ibig sabihin, na-combine natin lahat ng my variables x, si x squared plus 4x, si y squared plus minus 6y din, then si z squared plus 2z, and then yung constant na 6 is transpose natin sa right side. Okay, so by completing the square, magiging x squared plus 4x, ito yung sa given natin, no? Kaya yan naging 4, kasi di ba kung i-apply natin yung completing the square, mag-times tayo ng 1/2 dito sa numerical coefficient ng may variable na x. So 4 times 1/2 is 2, di ba? So and then after that, squared lang natin. So 2 squared, that is equal to 4. So yun yung ilalagay natin dito. So kung nag-add tayo dito ng 4, mag-a-add din tayo ng 4 sa right side. So the same with y squared minus 6y, galing sa given natin class. Naging plus 9 yan kasi si 6, minultiply natin yan ng 1/2. So 6 times 1/2 is 3. And then after that, squared ninyo. So 6 times 1/2 is 3. 3 squared is 9. So that's why 9. So nag-add din tayo dito ng 9. Yung 6 na yan class, galing yan dito sa given natin. Then tinranspose lang, kaya siya naging negative. Then same also with z squared plus 2z. So this is 1 because 2 times 1/2 is 1. Then squared nyo si 1/2, 1 pa rin. Okay. So, para malaman natin yung center niya, kailangan natin i-rewrite yung equation natin in this form. So, x plus 2, saan galing si 2 plus? Yan yung result nung, dito sa first term ha, yan yung result nung nag-times tayo ng 1/2 dito sa numerical coefficient na may kasamang variable x na hindi pa na squared. So, di ba nag-times tayo dito ng 1/2, no? So, 4 times 1/2, 2. So, yun yung ilalagay natin dito, yung hindi pa na squared. Pero, so, ayat tigun nyo saya sa last term yan, basta lagayap na, di nyo panpasit yung logo so, center yan, nasa niya squared din. So, lagi dayang mambu. So, that's why 3 ito, kasi 6 times 1/2, that is equal to 3. Ito kasi naging 9 kasi na-squared na yung 3 dito. So, ito naman, 2 times 1/2 is 1. So, complete natin ito, that is equal to 8. So, comparing this equation with the standard form, we say that it is the equation of a sphere with the center. So, ang center natin dito, class, diba, ito yung formula ng sphere. Ibig sabihin, ang h natin, class, is negative 2, no? And then, si k natin is positive 3. And then, si l natin is negative 1. Okay, given ito na din yun, basta may lagi tayo din sa form yan para kuha nyo sa center yan. So, HKL, H na siya nang katuon sa ubay X, K na unang KY, si L na K, D. Positive sa yan, na yung center yan na negative 2. Kung negative si A, na ayag kuha nyo ang center yan na positive yan. So, opposite sign yan. Kung positive 1, ibig sabihin yung center niya is negative 1. Then, yung radius niya is eto. Okay. Ang equivalent ng 8 na yan, class, yan yung r squared. Okay, galing dito sa formula na yan. So, para malaman niyo yung r, kung r squared natin, class, is equals to 8, so squaring it both sides para malaman natin yung value ni r. Si r lang naman yung kailangan, hindi r squared. So we have r is equal to the square root of 8. Ang square root of 8 is 2 square root of 2. So ito yung radius ng sphere natin. Okay. The last topic in this module is the direction, cosines, and numbers. Pero sa next na module class is continuation pa rin ng analytic geometry in 3 dimensions ha. Okay, direction, cosines, and numbers. So ito naman class, formula lang din yung gagamitin dito. In 3-dimensional space, we consider a line passing through the origin O and place an arrow in it so that one of the two possible directions on the line is distinguished. So we call such a line directed line. Okay, kung may arrow, directed line. If no arrow naman is placed, then L is called an undirected line. We use the symbol, this one, to indicate a directed line, while the letter L without the arrow over it, indicates an undirected line. So we denote by alpha, beta, and gamma the angles made by the directed line L in the positive directions of the x, y, and z axis respectively. So we define these angles to be the direction angles. So si alpha, beta, and gamma class, sila din yung tinatawag na direction angles ng directed line natin na L na may arrow sa taas ha. Okay, the undirected line L will have two possible sets of direction angles according to the ordering chosen. So the two sets are the alpha, beta, gamma, and pi minus alpha, pi minus beta, and pi minus gamma. The term line without further specification shall mean undirected line. Okay, so pag nakita ninyo sa given example na walang nakalagay na directed line, ibig sabihin undirected line yun. So in this definition class, if alpha, beta, gamma are direction angles of the directed line, then cosine alpha, cosine beta, cosine gamma are called direction cosines. Okay, meron tayong directed line, meron siyang direction angles na alpha, beta, gamma, then meron din tayong tinatawag na direction cosines na cosine alpha, cosine beta, and cosine gamma. Since cosine of pi minus theta equals to the negative cosine beta. So we see that if lambda, mu, and nu are directed cosines of a directed line L, then lambda, mu, and nu and the negative and their negatives rather are the two sets of direction cosines of the undirected line. Okay, so etong dalawa na to, two sets na to, is sila yung direction angles ng undirected. And then, eto naman si lambda, mu, and nu, then yung negative ng bawat isa are the two sets of direction cosines naman ng undirected line. Ibig sabihin, pag directed line, isang set lang. Isang set lang yung direction angles niya at saka direction cosines. Pag undirected line class, dalawa yung sets ng direction angles niya at saka direction cosines. So, theorem 9.2 class, let cosine alpha, cosine beta, and cosine gamma be the direction cosines of any line L. Then, cosine squared alpha plus cosine squared beta plus cosine squared alpha equals to, gamma rather equals to 1. To define the direction cosines of any line L in space, is simply consider the line L parallel to, L, which passes through the origin, and assert that by definition L has the same direction cosines as L prime kasi parallel lang silang dalawa which passes through the origin. So thus all parallel lines in space have the same direction cosines. So yun yung tatandaan ninyo, lahat ng parallel lines in space have the same direction cosines. In definition 9.3, two sets of number triples A, B, C, and A prime, B prime, C prime, neither all zero, are said to be proportional if there is a number k such that a prime equals to k times a and b prime equals to k times b and c prime equals to k times c. Okay, so two sets of number triples class neither all zero are said to be proportional if there is a number k. So later on sa example, maintindihan natin kung ano yung mga tinidiscuss dito sa theorem na to at saka sa definition. So, take note, the number k may be positive or negative, but not zero. Since by hypothesis, neither of the number triples is 0, 0, 0, if none of the numbers a, b, and c is 0. So, we may write the proportionality relation as a prime over a equals to k, b prime over b equals to k, and c prime over c equals to k. Or more simply, proportional lang man sila. So, a prime over a equals to b prime over b equals to c prime over c. Another definition, suppose that a line L has direction cosines. Okay, tandaan yung symbol ni direction cosines. Alpha, beta, lambda, mu, and mu. Then, set of numbers A, B, C is called set of direction numbers. Okay, si A, B, and C naman is set of direction numbers. Okay, so recap natin. May tinatawag tayo na directed line. May tinatawag din tayo na direction angles. Those are the alpha, beta, gamma. Meron din tayong tinatawag na direction cosines na lambda, mu, and mu. And meron din tayong tinatawag na set of direction numbers na A, B, C. For L, if A, B, C, and lambda, mu, and mu are proportional. A line L has unlimited sets of direction numbers. Take note this. Okay, so theorem 9.5, if point P sub 1 and point P sub 2 are 2 points on a line L, and D is the distance from P sub 1 to P sub 2, then, okay, lambda is equal to x sub 2 minus x sub 1 over D, where D is the distance from P to P sub 1 to P sub 2, and then mu is y sub 2 minus y sub 1 over D, and then V is equal to z sub 2 minus z sub 1 is a set of direction cosines. So, atong tatlo na to ito yung set of direction cosines natin. Yan yung formula niya. Okay, si set of direction numbers, those are the numbers A, B, C. Okay, set of direction cosines, ito yung isasagot ninyo ha. So, corollary 9.6, if point P sub 1 and P sub 2 are two distinct points in the line L, then x sub 2 minus x sub 1, y sub 2 minus y sub 1, z sub 2 minus z sub 1 is a set of direction numbers. Okay, so ito na yung final na set of direction numbers. Si x sub 2 minus x sub 1, y sub 2 minus y sub 1, at saka z sub 2 minus z sub 1. For example, find the direction numbers. Okay, take note. Find the direction numbers and direction cosines for the line L passing through the points P sub 1, 1, 5, 2, and P sub 2, 3, 7, and negative 4. Okay, so from corollary 9.6 class, we have yung direction numbers. Yung formula ng direction numbers is x sub 2 minus x sub 1, y sub 2 minus y sub 1, and then z sub 2 minus z sub 1. So, substitution lang. So, ito yung point P sub 1 natin, point P sub 2. Sa point P sub 1, we let this as our x sub 1, y sub 1 magwaya, c5, and then c2 na z sub 1. Sa P sub 2 mabuna, x sub 2, y sub 2, z sub 2. So, ang x sub 2 natin is 3. So, magiging 3 minus 1 is 2. Y sub 2 natin is 7 minus 5, that is 2. Negative 4 minus 2 is negative 6. It is clear that 2, 2, and negative 6 form a set of direction numbers. Then, after that, we compute for the distance D para malaman natin or ma-obtain natin yung direction cosines. So, distance D is the the absolute value of the distance from P sub 1 to the point P sub 2. So, substitution lang din. X sub 1 minus X sub 2 pwedeng eto class. Bring down nyo na lang dito. Square nyo na lang. And then, 7 minus 5. And then, say, negative 4 minus 2. Square nyo na lang. So, ang distance natin is 2 square root of 11. So, applying the theorem 9.5, ang magiging direction cosines natin is, yung formula ng direction cosine, lambda is equal to x sub 2 minus x sub 1 over the distance d. Mu is equals to y sub 2 minus y sub 1 over d. And then, mu is z sub 2 minus z sub 1 over d. So, substitution lang din. So, ibig sabihin, paulit-ulit lang. So, yung nagamit ninyo sa direction numbers, magagamit ninyo sa pagkuha ng distance, then ma-apply nyo din sa direction cosines. So, si 3 minus 1, bring down nyo na lang din dito. So, 3 minus 1, nadagdag lang sa denominator si distance na 2 square root of 11. So, we have 1 over the square root of 11. Si mu naman is 7 minus 5. Okay, bring down lang dito si 7 minus 5 over the 2 square root of 11. So, we have 1 over the square root of 11. And then kay mu is we have negative 3 over the square root of 11. So, these are the set of direction cosines. Since L is undirected, it has two such sets. The other being is yung negative nila. So, di ba, sa first, yung obtain natin kanina is positive. So, yung pangalawang set niya is yung negative. Kung positive siya, kung negative siya, yung positive niya. Ibig sabihin yung opposite sign. Kaya natin ito nasabing na directed kasi wala mang nakalagay dito na directed line. So, di ba ang sabi kanina sa definition, the term line without further specification is specified as undirected line. So, ang sabi lang kasi dito, for the line L, nilagay dito for the directed line L, ibig sabihin, directed siya. Basta damilay nyo na directed lines kung given nyo na undirected na dito line. Tapos na ay duwa ka sets, so set of direction cosines yun. So, positive, so kumbaga kung lang positive na langon positive na iya, ikadwa niya na set na langon negative ng bu. Kung si ko first set na ana negative na, si ko ikadwa set na ana positive ng bu. So, bu, so opposite o umanisa. Another example class is do the 3 points P sub 1, P sub 2, and P sub 3 lie on the same straight line. Okay? So, kung graph natin yan, malalaman natin if they lie on the same line ba. So, for the line L sub 1 through P sub 1 and P sub 2, ang direction numbers niya is ito. Kung si P sub 1 and P sub 2, so ito yung direction numbers niya. Negative 2, 7, and 4. For the line L sub 2 naman, which is yung point P sub 2 and P sub 3. So, ito din yung direction numbers niya. 8, negative 28, and negative 16. Tandaan yan ha. So, since the second set is proportional to the first set, with K equals to negative 4, tama diba? Kasi, negative 2 times negative 4 is positive 8. So, proportional siya doon sa pangalawang set of direction numbers. So, the same din kung si 7 times negative 4, diba? Magiging negative 28. Tama ba? And then, si 4 times negative 4, magiging negative 16. So, proportional siya doon sa pangalawang set na direction numbers. So, we conclude that L sub 1 and L sub 2 have the same direction cosines. So, pag proportional yung dalawang set ng set of direction numbers ng dalawang line, ibig sabihin nun, parehas sila ng direction cosine. So, therefore, the two lines are certainly parallel. Basta the same sila ng direction cosines, ibig sabihin nun, parallel yung dalawang line na yun. However, they have the point P sub 2 in common and so must coincide. So, the answer is yes. Okay, so we have the corollary here. A line L sub 1 is parallel to a line L sub 2 if and only if a set of direction numbers of L sub 1 is proportional to a set of direction numbers of L sub 2. Okay, so yung corollary na yan, na-justify yung sa example 9.8 natin. Okay, so the angle between two intersecting lines in space is defined in the same way as the angle between two lines in the plane. So it may happen that two lines L sub 1 and L sub 2 in space are neither parallel nor intersecting. Such lines are said to be skew to each other. So nevertheless, the angle between L sub 1 and L sub 2 can still be defined. Denote by L sub 1 prime and L sub 2 prime. The lines passing through the origin are parallel to L sub 1 and L sub 2 respectively. The angle between L sub 1 and L sub 2 is defined to be the angle between the intersecting lines L sub 1 prime and L sub 2 prime. In theorem 9.10, if L sub 1 and L sub 2 have direction cosines, okay, kung may direction cosines tayo na lambda sub 1 rather, mu sub 1 and mu sub 1, lambda sub 2, mu sub 2, and mu sub 2 respectively. And if theta is the angle between the line L sub 1 and L sub 2, then cosine theta is equal to this. Lambda sub 1 times lambda sub 2 plus mu sub 1 plus mu sub 2 plus p sub 1 times p sub 2. So in corollary 9.11, two lines L sub 1 and L sub 2 with direction numbers, okay, respectively are perpendicular if and only if ito siya is equal to 0. In example 9.12, find the cosine of the angle between the line L sub 1 passing through the points P sub 1 and P sub 2 and the line L sub 2 passing through the points Q sub 1 and Q sub 2. So, ang hanapin natin dito is the cosine of the angle. Okay. So, gagamitin natin yung formula sa previous slide. So, a set of direction numbers. But before that, kailangan muna natin hanapin yung set of direction numbers ng bawat line. So, a set of direction numbers for L sub 1 class is, ito yung sa L sub 1 ha, ito yung point na gagamitin natin. And then, for L sub 2 naman is itong points na ito. So, 3 minus 1 is 2. And then, negative 1 minus 4 is negative 5. And then, 3 minus 2 is 1. So, a set of direction numbers for L sub 1 is 2, negative 5, and 1. A set of direction numbers naman for L sub 2 class is 2 minus 3 is negative 1. 1 minus 1 is 0. And 3 minus 2 is 1. So, ito din yung set of direction numbers na L sub 2 or the line 2. So, solving for the distance D for L sub 1, ang ma-obtain natin na distance is the square root of 30. Okay. Ang set of direction cosines naman ng line 1 is ito siya, 2 over the square root of 30, negative 5 over 30, and 1 over the square root of 30. Formula lang po ito. So, review nyo lang yung previous examples. And then, solving for the distance D for the line L sub 2, kasi magkaiba sila. So, ang distance na ma-obtain natin sa line 2 for L sub 2 is the square root of 2. So, the set of direction cosines for L sub 2 class is this one, negative 1 over the square root of 2, 0, and 1 over the square root of 2. So, iba din yung direction, set of direction cosines for L sub. Therefore, so this is the formula yung na-mention dun sa theorem kanina. Cosine theta is equal to lambda sub 1 times lambda sub 2 plus mu sub 1 times mu sub 2 plus mu sub 1 times mu sub 2. So, substitution lang po. So, ang lambda sub 1 na nakuha natin sa L, pag lambda sub 1, ang kukunin natin na result is yung sa L sub 1. Kung 2 naman yung subscript, ibig sabihin yung sa L sub 2 or line 2 yung isa-substitute natin. So, sa lambda sub 1 ng lambda sub 1 is 2 over the square root of 30. So, galing dito. And then, sa lambda sub 2 naman is sa line 2. Okay, so yun yung tatandaan ninyo ha. Kung ang subscript is 1, line 1. Kung subscript is 2, line 2 yung kukunin ninyo na result. So therefore, the cosine theta is negative 1 over 2 square root of 50.